Okay.
All right. Hello, everyone. Today we're going to be talking about different coding patterns that are used when developing applications, specifically two, MVC and MVVM. I'll go over the first one, MVC, and then Alex will go over the second one, MVVM. And I'm also going to give an example of my coding pattern, MVC, using ASP.NET. So yeah, I'll show that. Hopefully you can see my screen here on the right. So MVC stands for View, Model, View, and Controller. And it's named after the three components that make it up. And it's one of the most popular coding patterns, and it helps to simplify and code and ease development. And this can be used for pretty much any application, so mobile, web, it can be applied to that. And it's not like a strict set of rules, it's more like a guideline for simplifying the process. So going into the three components here, I'll start with the model right here. And this model is going to handle all of the data logic. And as you can see, it's going to interact with the database here. So it's going to query the database and do whatever it needs to do with the data. Over here, we have the view, which is going to handle the presentation of the page and dynamically render it. And most likely, depending on the application, so like with a web app, it will be returning a collection of HTML items. And then finally here, we have the controller. And this controller kind of serves as the brain of the application, and it handles the request flow. So it handles requests from the client and also interacts with both the model to get the data and the view to get the presentation of the data so they can return it to the client. And it's important to note that the controller doesn't actually do any of the data logic itself. That's done in the model primarily. So it'll just get the data from the model. And I kind of alluded to it a little bit already, but there are really 4 key steps in this process right here. So the first thing that's going to happen is the client is going to make a request to the app, and that request is going to go to the controller. The controller is then going to get any data that it needs, if the request calls for that, from the model. And so it will make a request to the model. The model will query the database if it needs to and do any data logic that's necessary, and then return that data to the controller. And then the controller will make a request to the view, sending the data if there is any. And the view can then format that data, send it back to the controller, who can then send it back to the client. There's also, should be noted that there are other ways that you can implement an MVC, so you can have these interact with each other. But in this example, and in this model diagram I have right here, there's never any interaction between the model and the view. So they're separate in this. And that's really just done to keep the development simpler, because it's more complicated if you have more interactions between different components versus just having the one that interacts with both the model and the view. And before going into the code, I just want to give like a quick example of what this process might look like with some actual, a more concrete example, I suppose. So let's say that the client wants to make a request for a list of movies. And so that request is going to go to the controller. The controller is then going to make the request to the model for the movies, which the model is then going to query the database, and it can filter the movies if it calls for that. And if it finds movies, it will return them to the controller. The controller will then make a request to the view, and the view will, so if there is data, then it can format that data. It can be like in a list format or a tabular format, and then return that to the controller as a collection of HTML items. Or if there isn't any data, it can also do a presentation of an error page in case like it was a faulty request on the client's part. And then the controller will then return that presentation to the client so they can see the web page or the applications page that they were requesting and looking for. So I did make as I said, a small web app that kind of shows this off. And in this, I'm using Visual Studio. So not Visual Studio Code. Visual Studio here, and you'll notice I have it in light mode. That's just how I had it set up initially. And what's really nice about Visual Studio is that it gives you a lot of templates to start from. And one of those templates is MVC. So I was able to use that template to really streamline making this app, just pretty simple app here. And it created 3 folders you'll see right here on the right, 3 key folders. We have the controllers, we have the views, and I missed it, but we have the models as well. So all 3 of the key components here. I'm just gonna, so there's two different like MVC schemes. So two different controller model view setup. So the first one is just a real simple hello world setup. And this is what I have right here. Oh, I should note, I'm also writing this in C#. So I always think of it as being similar to Java, but I've also heard people say it's similar to C, which it definitely is. But anyway, this web app is made in C# and it's using ASP.NET. So here I have my hello world controller. And this controller is going to handle GET requests from the client. So if the client types /hello world, in addition to the URL, or hello world/welcome, then it will either call this index or the welcome in order to handle their request. And we'll start by looking at the index real quick. It's going to return the view. So it's not going to do any sort of request to the model or any sort of format. I think it's just going to return the view. And that view, if we go here to our views folder, we also have a subfolder called hello worlds. And conveniently, we have this index file right here. And it's a collection of HTML items. So we have a header, and then we have a paragraph. And that's all it's going to do, is just return a real simple web page where you have this index request. And then in the second request right here, we have this /welcome. And you'll notice it has two parameters right here. And these can be passed along with the GET request in the URL. So if you type a question mark and then name equals Adam, I'll show that in just a moment. You can pass the name along with it. And I also have a default value here for num times. So it'll make more sense once we see the view, but it's just gonna, the controller right here is just gonna set these two attributes right here of the view bags, the message and the num times. And then the view here, we go to the welcome page or welcome view, we can see that it's gonna create a list of all of the messages in the bag. It's gonna do that num times. And right here, something that's cool with ASP.NET is that you're able to write C# code in your HTML using this little @ sign right here. So I have this for loop, and it's returning a list element for each number of num times, each iteration of the for loop. So that's pretty nice. I like that. I'm going to start this. And while I'm saying that, I will mention that there's no models in this, so there's no data. So we don't need a model component in this simple example here. It'll take a minute to start up, but it should start up in just a moment. There it goes. And it's just running on localhost right here. Okay, there we go. Here's the home page. I'll just type the hello world. And here it is. It's the simple header and paragraph HTML items that we were looking at before. And then I can type in /welcome. And you'll notice I didn't pass any sort of name. So we go back to the code here. There's no name. So when it rendered this, here, when it did the first iteration of the for loop, there wasn't any item in the bag. So it just created this list element with the word welcome or hello in it. So now I can pass in that. And it has my name. And I can pass num times as well. And now it says my name 3 times. That's the simple demonstration to kind of understand how the ASP app is working. And now I have a more complicated example using the movies example that I was going through with the picture. So likewise, I have a controller for the movies called movies controller. And this is going to handle the GET request. So get movies as an index. And then it also has other things for details and then the other create, edit, other CRUD operations. And so we have this right here. It's going to return views. But before I go into that, I do want to show off model here, since we have a model this time. And this model right here is just a class. So we have a movie class and it has different attributes like the title, the release date, and the genre. And then to link it with my database here, it's a MySQL database. I use this DB set, and I also added a configuration string, I believe is what it's called, down here in this web.config file to make it work. And this is going to create a collection of my movies that's from this database. And if I open it up here, I have in my app data file a movies.mdf, and there it goes. I have my database, and in the tables you can see my movies table. And loads in just a moment. Oh yeah, I'm opening up the design. I don't want the design. I want the table. So I'm viewing the table here, and you'll notice that there's one item in it, just one movie. And then I can add more if I want to. And then each of these attributes is a column. And so that's the model part. That's the data, and it links to the database. And then if we go into the view portion, you'll see here in the views folder, I have a folder specifically for movies. It has folders for the CRUD operations, and here we're going to look at this index right here. And this index is going to create a table. It's going to present the table, the movies in tabular form. So it's going to, here we have the header of the table, and I have like columns for title, release date, genre, so forth. And then similar to the other example we had before, we had a for loop with the @ sign. Here we have a for each.
Can you hold your mic closer? You
Sure.
keep going back out.
Sorry about that. So like before, where we had this for loop written using this @ sign, over here in this index file for movies, we have a for each loop. And it's going to create another row of data for each movie we have in our model. And it's just going to display the attributes here. And then we do have separate pages for edit, details, and delete. I'll show those in the web app. I'm not going to walk through the code though. And so I'm going to start it up real quick. And unlike with the Hello World simple application where I just had to type it in the URL, this time I'm going to have buttons to click on, so I won't have to deal with that. Here we go. It already took me here, but if I click on that, it'll also take me to this page. And we can see the one movie that was in the database, and it's presented in tabular form. So we have the title, release date, genre, and price. And then we have that for each attribute of the one movie that's in the database. And then we have buttons for edit, details, and delete. I can also create a new one. So this will take us to the create page. And we'll just add a movie. I want to say this was right there, 27th. And I'll put it down that. And down a price. And now we can see we have a second item there. And since it is saved in a database, it will persist through refreshing and restarting the app. I can edit it here, and I'll just change the price. Save that. And now the price has been updated. Go into the details, and I'll list out all the different stuff. And lastly, I can delete it and confirm. And now it's gone. It's no longer in the database. And that was everything I wanted to show with Model View Controller. Kind of finished early there. Anything you want to add, Alex, before taking over for talking about MVVM?
I think it's pretty good. Jonathan, do you have anything you want to add?
No, I mean, that was pretty comprehensive.
Sounds good. I'll pass it off to Alex.
Okay, sounds good. So the first thing I'm gonna go over is what MVVM is, and then I'll contrast that to MVC. And there's a total of like 3 different patterns. We're covering 2 of them. The third one, I don't think it's as popularly used, at least in the world of .NET, is where I got introduced to all of these terms. So we're just gonna cover MVVM and MVC for today, and then some other best coding best practices later on. So let's begin. So first thing with MVVM, which stands for Model View Model, or Model View View Model. Here's a diagram of what that looks like. Basically, let's take an Android app, for example. An user is going to be able to access a page, which is your view. So let's say like a button or a counter, the cookie count clicker. So you click the cookie and then you can increment the count. So when they press that button, the command is going to be triggered on the view. And inside that view, you need to trigger an internal command, which is referenced inside of its own respective view model. So every view has its own view model. So basically, it's like its own little code underneath of it. So the code is triggered all in this view model. So it doesn't deal with anything on the UI. So none of that button stuff. That's all handled on the view. And then if it has internal like its own model inside of it, so like what Adam was showing with like it's basically a class. That's all a model is. So object-oriented programming, you can think of like that. And so you have all your, let's say like a list of people in there, you can update into a database or something. So that would be on your model. But if you don't have any of that, you don't really need a model. You can just have your view model. For the cookie clicker, it's so simple, you don't need a model. But if you did, you can read and write to it from here. And then you update the local variables in your view model, and then it's binded to the view. So any changes that happen onto your variables locally in your view model will be updated on the view, and you can handle what happens there. So I'll show that in an example with the Android app. So in contrast to MVVM, there's MVC. You can ignore this one for now, the middle one. So in the MVC, you have your controller, and it talks to the views and the models directly. So whereas in MVVM, you have your view talk to its own view model, and then before it talks to the model. So controller is basically taking care of everything. And you pretty much have all your view models in the side of this one controller instead of it inside of the view. The view is just the view, and you always have to talk to the controller. And I find that for Android apps, iOS apps, even like anything that has some sort of UI involved, I would go to MVVM. Now, if I was building an API, I find that building an MVC app would be better because there is no views associated with an API. You just have your routes. Let's like get, put, post, and delete. So then you route all of those operations, however many you have, and then they can go to its own subcode in there and do the model. So basically, MVC for APIs is my tendency, and MVVM for anything that has some sort of UI. But you can still do MVC for UIs like Adam showed with the ASP.NET, which ASP.NET, just to clarify, is meant for websites. Is that right, Adam?
Yeah,
Okay.
primarily websites.
If you want to add something here, I gotta open my door real quick. So I'll be back in a minute.
At the very least, I've only ever used ASP.NET for web applications.
I'm back. Okay. So yeah, that's it, MVVM. And so let's go to an example. So let's say we have this Android app here, and like that cookie counter thing. So the button here is pretend that's your cookie, and this is going to be what's showing your number, basically. So I just have two UI elements on this one page, and typically, what you would do to write your Android app for this is in your onCreate method, you're going to set your count equal to 0 initially. You instantiate all your UI elements, like your button and your text here. And for every button clicked here, I'm going to increment the count and then update the text to show that. For this example, and for even many small projects, this is going to be just fine. Now, as you actually start to build like an app that would be published on the store, so something that would be production ready or something of some sort, this is not going to work, because when you start to have 20 pages or so, and you need to reuse files, or things are just getting too clobbered and everything, or maybe you need to make it one for Android and iOS. That's the main reason why I would switch to MVVM, is because I've got to build something cross-platform, Android and iOS. And if I'm building a native app, so those are my requirements. So then therefore, it's going to be too hard to just write all the logic internally on the UI, because the code base is different in iOS than it is on Android. And you can't just keep on going back and forth. It just takes too much work. So that's the point of MVVM and MVC in general, is it saves you time in the long run for making for bigger projects. Now, if you're doing something like a hackathon, I don't think that would matter too much. So that's just some reference here. So here's the original, what you would typically write. And now here is the same view, but now it's going to be different. So we still have this. You can ignore this line. This is just to suppress some error warning messages. We have the same onCreate here. In fact, let me just split this to the right so we can compare and contrast. So I no longer have this local count variable here. And I still have my UI buttons and text configured here. I have my set onClick listener. So these are all UI element stuff. But you notice that there seems to be even more code than before. And that's why I was saying, for small projects, you probably don't want to do this unless you get used to it. And it'll be a good habit, I guess. You'll have to declare these view models things now. And you'll have to do this for every view that you're doing. But as I'm saying, it will save you time in the long run, and it's good to do. So now you see that none of the count logic is implemented locally here. It's all abstracted inside of this thing called a view model. And with a view model, you have to declare a new class, which inherits the capabilities of being a view model. So that's what this extends means. So I have a method here I want to call onCreate. So you'll see that I set the count equal to 0. And that's basically what's happening here. Count.set value to 0. So it's no longer here. I call the method viewModel.onCreate here. And if every time I click the button, I want to increment the count, that's done here now. So you have all these nice functions here, and it's pretty clear as to what's happening here. Now the UI doesn't really look like you know what's going on here. But if you just read into it, it's pretty clear. And once your code gets a lot bigger, it'll be a lot easier to manage, because now you don't have to put like 200 lines of code on your view. It's all handled on the UI, on the back end here, which is pretty easy to transfer over to iOS or web even. And so I have this count here. This, instead of it being declared as an integer here, I have to declare it as immutable live data. So that's what I was talking about before with a binding, because you can't, a local variable will still be treated as a local variable, but how do you let the view know what's being changed? So you declare it as a mutable data. Now the terms change over different platforms, but Android, this is what it's called. It's of type integer. I call it a count, and it's initialized with the value of -1. So on create, I set it to 0, and every time I want to update the count variable, I call set value. And if I want to get, I call get value. So set value, once this happens, I have this here called viewModel.count.observe. This is just like boilerplate code that you always have to type whenever you want to listen to the variable changing. So every time this changes, I'm going to update the UI's text. So I don't have the emulator available on my computer because it doesn't support it, but all the code would still work the same as if it were written here. So this is just some important thing to know, especially when your projects get a lot bigger. Nothing you need to know if you have like less than, I don't know, 10 pages on your app, or don't need to cross-platform it to iOS, then I wouldn't worry about this too much. But usually when you're working in an industry of some sort, they're gonna make you do this eventually, because they have their own purposes as well. Because another good thing about doing MVC or MVVM is that you have the ability to unit test or just do any sort of testing on your code. As you can see here, like how are you supposed to test an Android app? Like a user clicks it, yeah, there are actually things that do that, but it's not very easy if you just want to test a subsection of your code. So you want to test some internal logic. Let's say that if a user presses this button, it's supposed to make an API request. Well, you can let's say you only want to test the API request part of it, okay? Because the point of you testing is that you can test certain parts of your code, and if a bunch of all those small things were tested and working, then you're more confident that your big final test is actually going to work. So when you press this button, it makes an API request and updates all the UI and stuff. So let's say this function was in charge of making an API request. You can write a unit test case for that, and it would, if it passes, it passes, if it fails, it fails. So you can do that here, and it's a lot easier to test than if you did it on the UI. With UI, you would have to use a special framework for that. I think that's all I want to cover with MVVM. So a bit of a short workshop today. But I guess, Jonathan, you can talk about any best practices that you've learned along your journey.
Oh, let's see. Trying to think of anything that would be useful. You know, all of it's just like a too specific to each project. I guess that's one thing you could keep in mind is you know, make sure you're designing your application and also your practices as a team, if you're working in a team, to fit the individual team and project. You know, just because you use one system on one project doesn't mean that system might be the best for any other that you do. Not so much an architecture thing, it's just a programming lesson. But that's something that comes up a lot. Is it really good to be flexible whenever you work on something new, to understand exactly what's best for that individual project.
Do you have any examples of projects that you've had that you've figured out that you had to modify
Yeah.
your codes and all that?
Yeah, so one architectural change I made at some point, or one project I was working on, generally I tend to write my applications in Angular. But one project that I joined had multiple contributors who were not familiar with front-end frameworks. They had only worked with you know, pure HTML and CSS. And I was kind of coming in as like I guess you could call it a principal, I don't know, like a lead developer to kind of rework the project. But considering that the team's experience was in very plain HTML, CSS, JavaScript. I actually specifically avoided using a front-end framework and found something closer to that level, which was a templating language, to make sure that they were comfortable editing the code as much as I was. Which you sacrifice the advantages of a front-end framework, which are certainly there, but you gain the ability for everyone to be productive on the project, and that's really important.
Cool. Actually, there's one thing actually come to my mind that we didn't get enough time to discuss about databases. That actually is also a really cool best practice, and that's ORMs. So that stands for Object Relational Mapper, and basically, let me pull it up so I can explain while showing it. With the ORM, as many people who aren't necessarily strong with their database, or that's not something they're specialized in, they typically like .NET people. I think this is where it's most strong suited, is with .NET, for example, people don't want to write in SQL. There's security concerns with it, and it's also just harder to manage and test. Whereas for .NET, people are usually writing in C#. So how do you, writing C# and SQL, basically, if you want to write in SQL, you have to wrap that in quotes, basically. So how do you know that you made a simple mistake or something was wrong, or you want to make some drastic change? Modifying every SQL statement call that you have inside of your application code isn't gonna do the job in the long run. So what you have to do is insert ORM here. So you can write, in this example picture, you have your own Python code. It be whatever you want, .NET, Java, iOS. You have your own code here. You talk to an ORM. It'll interpret all your commands into SQL statements. So basically, you're writing in your own native comfort code. So Python, C#, Java, or Swift, whatever you want. And then it'll interpret all the SQL commands for you. So that's what's nice about ORM. And so here's a diagram from Entity Framework, which is Microsoft.NET ORM. And ORMs can go both ways. So you can, Entity Framework here is the ORM. So just letting you know. Let's say you wrote the database first, or someone else wrote the database first, and you need to get into your logic. How do you communicate with the database in an effective and long-term approach that's going to be working in the long run? So you can have your database here, and you don't want to write SQL. You can't write SQL, okay? So you can read all the tables. That's what Entity Framework is capable of. Then scan it, and then produce basically your ORM entities and stuff. So entities are like your table objects, each table. So like a person has age and name, that can be one table. Let's say pets is another one. So that has also age and name on there, and breed maybe, or type of animal, pet that you have. So they'll create two separate entities here, and then you can make calls to those entities internally. And you never have to touch SQL again. The other way is, let's say you're starting from application logic, okay? So maybe you're a smaller team, okay? You don't have like a database team. You're working on yourselves, you're working in a small group. You don't have, or maybe you're just creating the project ground up, so you don't have a database first. You have now the option to start by creating a database through your application logic instead. So that's basically what this logic is. Pretend this is your application logic. You define your entities here and all the relationships. So let's say a person can have many pets, but one pet can only have one owner. That kind of foreign key relationships. You define that all in your logics here. You define those tables, and then Entity Framework would translate that and update it into your database. So again, in your application logic, you also have to specify like the host username and password to your database and all that stuff in order to actually update the database you're specifying. So that's basically what ORM is. And Entity Framework is popular in .NET. There's other options for like Node.js. You have some, I don't remember what it's called, SQLize or SQL, or there's also Prisma, which is the one I prefer right now because it's pretty nice and it's new. But not too new in the fact that it's not good. It's pretty good. So those are some of the names to throw around. I guess I also want to mention that .NET is it's a new term that we just introduced in this workshop. So I want to clarify that .NET and PHP and something like Node.js or React or something, those are like 3 different ways to look at building a full stack application. Full stack being your database, your backend, your front end, and whatever else might be included. So .NET pretty much started as a backend. So everyone doing like APIs. You want to insert something? All right. Okay. So yeah, .NET basically started as a backend, I think, from a perspective where you're writing C# as your main logic code, or Visual Basic if you want to go even further. And Node.js and React, they started from a JavaScript perspective, so all the front end related stuff. And to make things easier, PHP was kind of introduced after .NET, and because .NET was kind of built for enterprise solutions for making all the security and all that stuff. So it totally has all the best practices enforced in .NET when you get it. So that's why for a lot of people it can be pretty overwhelming, and whereas Node.js will be the more likely go-to solution because it's so much easier to get started with. Because a lot of those best practices aren't enforced in Node.js. So to find this middle ground, PHP was developed where you can like put a hybrid of JavaScript and backend PHP code. So PHP code didn't have all those rules enforced on you. So it was quite a bit easier. However, PHP, you still have to learn another language. So that's a big barrier. If you have to do front end and back end, you have to know 2 languages. So there's a lot of front end developers aren't necessarily specialized with back end, and it might be just too much of a hassle to learn a new thing. So how do we get these front end developers to learn back end? And there's quite a bit of employers will say that they're looking for a full stack engineer or a front end engineer, and really they're just looking for someone to do the whole thing, especially with a small business. So to bridge this gap, to make front end developers learn back end stuff, the Node.js was introduced. So this is why I interchangeably use the words JavaScript and Node.js, because Node.js is basically is a JavaScript runtime that allows you to run JavaScript code in the backend. So now you have your backend in Node.js, and you also have your regular vanilla JavaScript running in your front end. So you only need to learn 1 language. So that's where Node.js comes from. And I think because of that, PHP is like slipping away and not as popular for new businesses today that are starting up, like e-commerce or something. Or, well, at least any businesses are planning on building writing their own code bases. So for that matter. But .NET is still being largely used. And at one point in your life, eventually, you'll find that the hassle with Node.js, because there's no enforced best practices, or there's some best practices that you may not have known about, or security features that .NET provides. And eventually, at least in my personal experience, with working a lot of small and bigger projects, I'm starting to guide towards .NET and learning that backend after finding all these problems with Node.js, where there's things that I need, like an ORM, it comes out of the box with .NET, or the MVVM pattern that comes out of the box with .NET, whereas in Node.js you have to install all these third-party dependencies and all that stuff. So a lot of those things eventually might gear, if you want to build the whole thing or just build the backend, might gear you towards .NET eventually. But you can still get away with, you learn, if you have already the foundation to enforce all these practices, like Node.js, then go for it. Walmart, for example, is using heavily on Node.js and it's going just fine. So that's not to say that Node.js isn't bad, because it's still really good. So that's my 2 cents on that. Adam, do you want to say any last thoughts before we wrap it up? Or Jonathan as well?
No, I think that's plenty.
How so? Wait, what's funny about it?
Oh, that's plenty.
Oh, okay. Okay. Well, in that case, I guess next week we're gonna be doing our presentations for all the clubs. So, I mean, not the clubs, for all the projects that are coming up. So whoever has whatever project is, regardless of whether or not you're in a group, you can still participate and show off what you've got. And basically, we're going to judge on a few criteria, such as technicality, creativity, the usability. I know about usability. Basic things that you think about as judging. We'll release all the details later on. So, and also completeness of the project, I suppose. And whoever's project does the best, we'll hand out a little freebie award for however many groups there are, but at least $100 for the whole group. If there's more members than like 4 people, then we'll hand out more money. But that's the plans for so far. And I think for next term's projects, it's gonna change quite a bit. So we'll release details next week, announcing all the details of next term's plan for the club. But yeah, thanks everyone for coming. And I look forward to see you next week.